name is Alan Johansson, and I am a senior manufacturing engineer for Echo Incorporated.
First of all, we'd like to thank Echo USA for helping us out on our capstone project. Could you explain what Echo USA does?
Echo produces handheld outdoor power equipment for the domestic and international markets.
What is an example of a manufacturing-specific challenge for Echo USA outdoor power equipment?
One of the biggest challenges we face is producing this fuel line assembly. We currently produce over 1 million units per year, and we expect that volume to grow year over year.
What does this assembly look like?
The process involves 4 different pipe assemblies that are pressed inside of a grommet. On top of that, we also have a joint pipe that is going internally between 2 of the pipes to make up a full assembly, which is also secured on by a clip, and those 3 pipe assemblies are all pressed inside of one grommet. It is one of the biggest ergonomic and dexterity related assembly processes we currently produce, and we need to explore automation in order to achieve the future growth of the company.
Again, thank you for all of your efforts. It's been a great opportunity to work with you guys.
My name is Christopher Dahlhoff, and I'm a graduating student of the AMST program here at Madison College. So what we started with is Echo actually came to us and just gave us a currently manually assembled process of how they build their fuel line assembly. For the fuel line assembly, it consists of 2 pipes, one longer one, one shorter one, a joint pipe assembly, and a small retaining ring. The current manual assembly process is all done by hand by workers, and what they do is they take the longer pipe, the retaining ring, and the joint pipe. The worker dips the long pipe in water and places the retaining ring over the pipe. The worker then presses the long pipe onto the joint pipe and places the retaining ring in position. As you can see, it takes quite a bit of dexterity and time. The worker then dips it again and places the second line on the other end, like so, completing the fuel line assembly. For the fuel line assembly process that we used in our cell, we first took the barb and placed it into this center gripper in the lower location. Next, we took the short pipe and placed it into this top gripper up here. After that, the robot came in and placed the long line into this top gripper here. At the same time, it places the retaining ring over that line. At this point, the press cylinder will come forward, pressing the long line, the retaining ring, and the joint pipe together all at the same time. The robot then moves in, grabs the end of the barb, and moves it to the top gripper of the centerpiece. Once the robot is out of the way, the pressing cylinder will actually retract, driving the shorter pipe onto the joint pipe assembly, completing the fuel line assembly.
My name is Eric Leyland. I'm also a second-year student with the Automated Manufacturing Systems Technology program. So once we get this fuel line assembly accomplished, we need to then put all the lines into a rubber grommet. Right now, the assembly done at Echo is done entirely manually. You have people taking these lines and physically pushing them into the grommet. And as Chris said earlier, it is definitely not an easy process. And finally, the fuel line that was created goes in through the bottom hole. So this is what the finished product will look like. Now, in order to accomplish this, we came up with a series of steps here. So again, here is what we want to do. We want to get these 3 lines into the grommet. So in order to do this, the robot places 2 lines into the slotted fixture. Next, a top clamp will come down to clamp the lines onto the fixture, making sure they do not move. Now, in order to give the fuel lines rigidity, we insert steel rods into them to give them support and make it so they are able to be pushed into the grommet. Once the 2 lines are into the fixture, like I said, they're clamped down, and steel rods will be pushed into the lines by a cylinder. Once they are pushed in all the way, the top clamp will come up and this bottom fixture will get out of the way and move out of the area. We then have another cylinder here pushing the lines into the grommet that will be situated in a fixture and placed by the robot. A top clamp will come down to make sure the grommet does not move. Now that the 2 lines will be in the top, we also need to bring this bottom fuel line that was created over there through the bottom of the grommet. Now we do that by the robot placing the fuel line over in this fixture on the other side. Once the fuel line is in the fixture and it is clamped down, a bottom rod will go through the grommet bottom hole and through the line that is placed in the fixture. This cylinder will then extend with the gripper clamped and drive the line through the grommet, with the bottom rod giving it support. And the cylinders are tied together so they move at the exact same speed. Once that is accomplished, the clamp on the grommet will come up and you will have a finished assembly. This project encompassed many different types of cylinders as well as machine parts for our hard automation. We had multiple rotary cylinders that rotated at 90 degrees, as well as slides and non-rotating linear cylinders. The biggest challenge with our hard automation was integrating it all together. So we had a total of 14 cylinders with our hard automation, And making all those work together with the rotary and the linear cylinders and the slides was definitely a challenge, and trying to figure out the stroke lengths and bore sizes as well. The PLC we used for the project is a Allen Bradley ControlLogix with an L63 processor. We use the PLC to actuate and monitor all areas of our hard automation. So this included sequencing our cylinders, as well as communicating with the two robots, the FANUC and the Yamaha, as well as getting data from our sensors and as well. The biggest challenge to the PLC was getting it all to work together. We had over 14 outputs as well as many more inputs, so getting all that to talk to each other effectively and getting what we want to do in sequence was definitely the biggest challenge.
For our capstone project, we used a FANUC LR-Mate 200 IC provided by FANUC. The robot we used mostly for just material handling. The single biggest challenge that we faced with the robot was the movements. We had to end up designing an end-of-arm tool specific to the part so that we could get into very tight locations and handling the very small tubes and pieces for this assembly. The HMI that we use for our project is a PanelView Plus 600 provided by Allen Bradley. The primary purpose of the HMI in our application was for machine control, data collection, and a maintenance mode. The biggest challenge that we faced with the HMI was being able to get it to communicate to all the components, including the two robots, all the hard automation, and the valve banks.